Hey everybody, this is Mr. Munson, and I'm going to be doing a quick review of some problems. This is not extensive, and it might be longer than it needs to be. And so the cool thing is when you're watching in the YouTube like this, you can scoot the video along. If I'm explaining something, you got it, just move along into the next problem. But I'll have the answers up here as I go through the thing, and you can just check to see how you're doing. You can download this page and the documents for this by clicking on the link that's in the comment section below the video and print up your own version of it. All right, let's get started. So again, I'm going to just take a pause. So at any point you put me on pause before I get to the next problem. That way you're not just copying down answers. You can think about it and then come back and do it. So just go into problem number 1. It says give the following condition. If a mammal has wings, then it has a bird. Underline the hypothesis and circle the conclusion. Put me on pause and then come back and check your work. Okay, so you should have underlined mammal and wings and circled it is a bird. Okay, make sure you're not doing anything with the if and the then. For the statement, if a polygon has 6 sides, then it is a hexagon. Now, let me just pause for a second because I should have told you at the beginning. Kind of stay with me. We're going to be dropping some of the problems that are on these pages, so you don't have to do them. We're not going to consider them in the video. So you might want to follow along with me or jump ahead and just see if I've done them, okay? If the polygon has 6 sides, then it's a hexagon. Write the converse. Go ahead and put me on pause and come back and check your work. Okay, so you should have wrote if a polygon is a hexagon, then it has 6 sides. Remember, the converse is when it moves. The converse shoes is the idea that I have to help you remember that. Write the inverse. Put me on pause, come back and check your work. If a polygon doesn't have 6 sides, then it isn't a hexagon. None of the pieces moved. I just negated them. Write the contrapositive. If a polygon isn't a hexagon, then it doesn't have 6 sides. So the pieces moved and I negated them. Does the biconditional exist? If so, write it. So this is a point where you put me on pause and you should be able to answer if something's biconditional or not, if you can turn it into a biconditional statement. If you can't do that, I suggest that you go and do a real quick tab research, go up to Google and look up biconditional statements. How do I do that? Because if you just simply watch it, you're going to forget it again. That's how that works. I've already told you how to do this and you've forgotten, so you know that method is not working for you on this. So go do some research, come back and check your work. Okay, yes, because the original and the converse are true, so you have to go back and check to see if those are true or not. And they are, they're both true. So when you go to do this, you're going to want to create an if and then statement, right? So the if and then statement has 2 parts. It has the first part, which is basically the converse, the conclusion or hypothesis stuck in the first part, and the other piece at the last part. So it should read, a polygon is a hexagon if and only if it has 6 sides. Next up, number 3. Now number 3 has these problems right here. You have to kind of read through this. My if and then kind of gets in the way. But anyway, in any case, given the statement, if you cannot drive, then you are not 16. Let P be you are 16 and Q be you can drive. And now I'm asking you, which one of these conditional statements down below, A, B, or C, represents the answer? Put me on pause, come back and check your work. Maybe. There it is. Okay, there you go. All right, now let's look at these next statements. These are symbolic forms of statements. We have a P in the instruction that says Dumbo is an elephant, and Q is he can fly. And so now it's your turn to write these conditional statements. Take the symbolic form, write it in words in verbal form using those P's and Q's. Put me on pause, and then come back and check your A. All right, so you should have wrote Dumbo is an elephant and he can fly. Let's do the next one. All right, you should have wrote Dumbo can't fly or he is not an elephant. Whoops. Let me get rid of that can't. It should just simply say can. There we go. Dumbo can fly or he is not an elephant. All right, next up, put me on pause, come back and check your work. If Dumbo isn't an elephant, then he cannot fly. Next one, P, and then that funny arrow going in both directions. Do you remember what that means? Put me on pause and come back and check your work. Dumbo is an elephant if and only if he can fly. E, put me on pause, come back and check your work. Therefore, and that's the symbology for therefore, right? The three little dots. Therefore, D. So I'm writing, oops, I should have not wrote D. I should have wrote Dumbo is an elephant, right? I should have wrote therefore Q. My apologies. Okay. All right. F. It should have wrote. You should have wrote Q, then not P. And then last up, H. Put me on pause and come back and check your work. You should have wrote the symbols not P and Q. Next page. All right, so let's go on to this problem here. Find this on your paper. And so basically we're looking to take this information here and put it into this Venn diagram. Okay? See if you can do that without looking at the answer. Off you go. Put me on pause, come back and check your work, and then I'll walk through how to do it. All right, welcome back. So the first thing you want to do is you want to put in the one that represents all three things happened. Okay? That's the very first thing. You know, in this case, we're talking about cat, birds, and dogs. And so that represents the three people in that intersection of those people all have a cat, a bird, and a dog, of course. Then start working up, if you will, or go find the ones where they're talking about two things at one time. So here we have 10 people that have cat and a cat and a bird. So we're looking at this area right here to represent what we're looking at here. There should be 10 people there. Now, if you look, there's already 3 people. 3 people are already accounted for, so we should put a 7 in that spot. And we're just going to keep on working it. Now, if you were stuck and you couldn't do it any further, and this is a good reminder, you might want to put me on pause now and see if you can do the rest of it on your own. That's the way you learn. Okay, 31 people have both dog and bird. So a dog and a bird, that would be this intersection right here where you have yeah, that's probably a terrible choice there. We're looking at these people right here that have cat and dog, and that should represent, that should represent, where am I? That's the cat. I jumped up here. There we go. I accidentally grabbed that right there. Okay, so there should be 22 people in that intersection, and there is. Let me go back down and do the 31. 31 should be dog and bird. So now we're looking at this section here, dog and bird. And so let's see who's there. Yep, that will give me a grand total of 31 people. Okay. Now, if you keep on going up, it says there's 100 people that have a bird. Okay, 100 people have a bird. So what I have to do is I have to take this 28, this 3, and that 7, add those together, and then subtract it from 100. And that will tell me how many people are in that total circle for the bird. Now, you know, when I have 100 people in the total circle of bird, so 62 have not been accounted for already in those other regions. And so there we have it. So if I add up 62, 28, 3, and 7, I should get up to 100. All right, and again, if you were stuck, this is a good time to put me on pause and see if you can do the other ones. All right, so for the dog, there should be a total of 55 people there. And so that leaves me 5 to go in the other section because the other ones add up to 50. 60 people for the cat. And so I should have 31 left over because there is a total of 29 already accounted for in the other regions. All right, let's move on down to the next one. Now in the next area here, it says I want you to basically take these take that diagram and shade in the areas that represent people who only have a cat. So let me kind of show you one and you can go and play with the others, okay? So let's let this be the diagram that's up here. And so I'm just going to draw this case here, and then I'm looking for the region that covers only the cat. So that was people who have cats, and that's it. All the other regions of the circle cat include people that have the bird or have a dog. Okay? Now, see if you can do that for the rest of them. This was one for the cat. See if you can do the other ones. Put me on pause and come back and check your work. Okay, so this should be the people who have, let me get rid of some of this little garbage here. And this should be the people who have a bird only. And then this represents the people who have a dog only. Okay? Now, if you notice, this thing just came through and it helped me remember I forgot to account for everybody. It said it had 200 people in the diagram that were surveyed. Now, sometimes students make mistake and they add these people up, and this is going to be well over 200. And the reason is because when you add up those numbers, you start double counting people in the circles. What you really want to do is go and add up all the regions, right? So with your calculator, you go and add up 5 plus 19 plus 3, and you add up all these numbers here, and that gives you the total of people that fall into owning a pet, multiple pets, and so on. Then you subtract that from that 200, and in this case, I had 55 people. Well, that can't be because I have 62 just sitting right there. So let me go back and check this number. I think that might be an error. Okay, well, the good news is the 45 was correct. Just what I wrote over here is how I got it was incorrect. Okay, so it was really, once I added up all these numbers, I had 155. So I subtracted that from 40 or from 200, and that gave me that 45. Let's move on. So it asked how many people don't have a cat, right? So that's going to be that 45 up there. All right, try your hand at this next one and come back and check your work. So when we're doing this, these words, these sentences, when we're describing these type of Venn diagrams, they will either have, they always start off with some, no, or all. Okay. Now the all is an if-then statement. That's why I have if-then. So I could say all cats are, or oh, I'm sorry, all kittens are cats. All kittens are cats. So that's two different ways that I can express that Venn diagram, right? I can do it as a conditional statement. If it's a cat, if it's a kitten, then it's a cat. Or I can say all kittens are cats. Those are interchangeable. All right, let's take a look at these next ones. So I'm going to give you one of them so you can kind of see how to go ahead and cross through law of contrapositive. You know how I've told you that if an original statement is true, then the contrapositive is true? Well, that's the law of contrapositive. That's what that law is. That's what gives you the power to do that. But we won't need that in these cases. Okay, so let's look at the first one. If you take a ballot, first of all, it's saying give a corresponding diagram, draw the proper conclusion. If there's no conclusion, then write no valid conclusion. Identify whether you use law of detachment or law of syllogism, okay? If you take ballet, then you are a dancer. Amy takes ballet. So when I look at that, I come to the conclusion of that you are a dancer, that Amy is a dancer. Okay? And the reason is because the law of detachment says that if I'm given a conditional statement like this, and the first thing comes true, then the second thing automatically comes true. Think about it. Over here you'll see a Venn diagram. If Amy is a ballet dancer, right? I mean, if yeah, she's a ballet dancer, then she automatically is a uh, dancer, right? She has to be a dancer. If she's in the ballet, then or takes ballet, then she is a dancer by automatic. But suppose Amy was out here. This would be somebody that doesn't even take take a dance. All right, here's the next one. If you weigh less than 100 pounds, you have to sit in the back seat of the car. Tim sits in the front seat of the car. All right, see if you can come up with the answer for this one. It's telling you that he sits in the front seat. All right, now if you take a look at the original statement is this. If you are under 100 pounds, then you sit in the back seat. right? Now, if you look at the contrapositive of this, it says if you're not in the back seat, then you must weigh over 100 pounds. Hey, Tim is actually sitting in the front seat, which means he's not sitting in the back seat. So what I would conclude is that Tim must weigh more than 100 pounds. Now, this is the law of detachment. And that's a new way of just saying, hey, since the um, conditional statement that's given to me has a contrapositive and it's equally true, then I can apply this statement here to that contrapositive to come to a conclusion. Now, I don't want you to worry about this one. Okay, this one is a little bit higher level than what we're going to be dealing with on the test. But I want you to understand that in case you happen to see this on an SAT or something. If you are 16, then you can legally drive. John can legally drive. All right, see if you can come up with a conclusion. All right, I'm saying you can't. And it's basically this is the reason why, right? So if you're 16, then you can drive. So if the if part goes in the little circle, drive goes in the big circle, right? And so basically it says this: if I'm a driver, then I could be any age. These are the drivers that are 16. If I'm 16 years old, then I can legally drive, right? I should say the big circle is the people who are legally able to drive. It doesn't mean that they drive, but they're legally able. So it says John can legally drive. That just means he's anywhere inside the circle. He certainly could be 16, but there's no condition that says he has to be. So that's why there's no conclusion for this problem. Next one. Put me on pause. Check your work. Check your work when you come back. All right, and this last one is, I just put it in symbolic form so we could easily look at it. Basically, if you do your homework, then you do well in school. And if you do well in school, then you get, your parents are happy. So my conclusion is this, that if I do my homework, my parents are happy. That's an example of the law of syllogism. If you take a look at the result here, it was still a conditional statement. If it was that, hey, my parents are happy, or that I did my homework, if at some point it said, hey, you do your homework, then my conclusion would have been, hey, my parents are happy. That's the law of detachment, though. All right, so let's take a look at this one, letter C. All right, see if you can shade in the area for C and B. C and B. Put me on pause, come back and check your work. All right, this region right here represents the people or the things or whatever of C and B. C and B, right? All right, let's go on down to the next one. Name the shaded area you use in the set notation. Okay, so this is set notation. We're usually using this for and this for or. Okay, so see if you can do this one. All right, I have A and C. Right, that's the region, just similar to what I just did above, but a different region. All right, so let's see if you can do this one. All right, so that represents the or. It's you're either a B or a C, right? So a person could be here, and it's still true. B, that person's a B, that person's a B, that person's a B, that person's a C. So the B or C statement is still true. There's a C, that's still true, right? Okay. All right, here's a good challenging problem. See if you can draw a Venn diagram to represent cotton candy, junk food, healthy food, food in general, and then fruit. Okay, put me on pause. Come back, give it your best shot. Who cares if you don't get it right? You at least tried it, and you can see what I did and see if it makes sense to you. Okay. All right, welcome back. That's what I have right here. Oops, everything got disjointed here. Oh my goodness, every piece got separated. All right, so I have a big circle that represents all the food. Then I have a junk food circle with cotton candy in it. Then I have a health food with fruit in between it. And there's no overlap between junk food and healthy food. Okay. Now there could be, other foods that are, neither healthy or junky food, right? So that's why they're not, they could be, someplace over here or something. Okay, now let's see if you can do the next one. See if you don't get too big of a hint here. Polygons, triangles, squares, and quadrilaterals. See if you can come up with one for that. Okay, welcome back. So how about this one? I have a circle that represents all polygons, right? And so polygons are shapes, if you didn't know, shapes with edges. So circles wouldn't be inside this thing. So I have squares that are quadrilaterals, and I have triangles, and there's no overlap. There's no such thing of a four-sided figure and a three-sided figure at the same time. So there's no overlap. All right, see if you can do this next one. They say let A be this and B be that and C be that. And then it says how many students are in the place where A and B are true. Okay, explain what this means to you in words. Okay, so take a look at that, put it on pause, maybe shade it in and describe it in words. Also tell me how many people. Put me on pause. Okay, A and B is going to be the area, right, is it A and B? Yep, A and B. I think I might even have a wrong answer here, so let's fix that. A and B is going to be this area right here. And so I should have 9, which is not true, 15. So I've got the A and B, right? So that's 9. And then, let's get this out of the way. And so that represents the students that are taking algebra and bio. All right. Well, it's continued on the next page, but it's that drawing from the previous page that they're talking about. It says, how many students are in B or C? Explain your answer. Okay, so go ahead and see if you can figure that. B or C. Put me on pause. All right, for me, I got 72. This is how I got it. I added up all the regions that were in the B region and the C region total. So I got a 4, I got a 5, I got a 7, and a 32. That all came from the B region, my visual perception of B, right? And then I'm going to add to it anything that I haven't covered already in the C region, 10 and 14. Those all add up to 72. All right, what's the next one? Next one is how many students are in A? Explain your in words there. Put me on pause, come back and check. All right, well that represents all the people in the region of A, 23, 10, 5, 4, right? Those are all those separate little regions. They add up to 42. All right, let's see if you can do this one, right? It's a Venn diagram. You're going to need to create 3 circles because there's 3 different things. You can see right here, this one. That's going to be the one that you're going to want to start off with, right? Because it includes all 3. And so they're talking about comedies, horrors, horror movies, and action movies, okay? Now, just so you understand so that your numbers can play out the same way mine do, I set up my 3 circles like this where comedy's in that one spot, action movies are over here, and then horror movies are down here. Okay, so if you want to set it up like that so that your numbers will be easily compared to my numbers, that's be great. All right, put me on pause, come back and check your work. Okay, again, I started with the 5, and then it said at some place 3 people like comedies and horror movies only, right? Comedies and horror movies only. And so this person right here, this 3 are people who like comedy and horror movies, right? But they don't like action movies. They only like those. So that's why I put a 3 there. There's a total of 8 people who like comedies and horror movies, but that's not the information they told me. Okay. All right. And so if you, again, if you got stuck, put me on pause, divert your eyes, and see if you can do some more of these on your own. Next one up, 11 people like horror movies and action movies. So now when I go to action movies and horror movies, it's not saying that they only like those. They just say that they happen to like that, right? So there should be a total of 11 people in that region. All right. And so then it says one person likes comedy and action movies only, right? Comedy and action movies only. So that's that person right there. There's a total of 6 people who like comedy and action movies, but this person likes only comedy and action movies. No horror movies for them. That would be me. 52 people like action movies, so I go down to the action movie circle, and what I need to do is make sure that I've got 52 people accounted for there. And so that leaves me 40 to be just people who like action movies. And I continue this process until I've gone through that whole thing. Now it says there's 98 people total. So what I did is um, I added up all these regions, right? And then I subtracted that number from 98, and that gave me the 23 that didn't like any of these movies, which is the answer to this question right here. Okay, off we go to this next section is match each of the following conditional statements with a property. So looking at these properties, I'm just going to talk through them real quick. If you look at the first one, A, it says if JK is equal to PQ and PQ is equal to ST, then the first thing here matches the last or equals the last thing there. This is called the transitive property. Maybe. Yep, there we go. C, transitive property. All right, how about this next one? If you look at this one, it starts off with S is equal to 3. Then all of a sudden on the S side, there is a 5, and on the other side is another 5. See if you can come up with this one. That's the addition property, right? I added 5 to both sides and changed it. All right, next one says if ST equals 2 and SUT equals 3, then this whole statement right here is equal to 5. So how did I go from this to 5? Put me on pause and see if you can figure out which one that is. That's the substitution property. All right, next one. If angle K is 45, then 3 times angle K equals 3 times 45, which is 135. That's a pretty easy one. You probably have that one already. That's the multiplication property. If the measure of P is equal to the measure of Q, then the measure of Q is equal to the measure of P. So the statements got flipped. And that's in the world of logic, we would call that the converse. But we're in the world of equality, so we're going to call that the symmetric property. Things can be flipped like that, and it doesn't change the equality. All right, up next are two proofs. See if you can put that information in. Certainly consider drawing from these properties up here if you can or need to, okay? Go ahead and do that. Put me on pause. Come back and check your work. All right, there you have it. It's pretty self-explanatory. Hopefully you can figure it out from what I wrote. You know, I have the division property down here at the bottom. I have the distributive property, kind of abbreviated as the subtraction property. All right, we're going to skip the next few proofs and we're going to jump down to the review section. So just take a few moments, put me on pause, come back and check your work on all of these, okay? And we'll finish up from there. So you're looking at the distance, midpoint, and I can't remember the other one. But anyway, go ahead and put it on pause, come back and check your work. Right, finding the distance. I like using Pythagorean theorem for that one. All right, that's all I have for you. Hopefully you found that helpful.